This is the review video number 1 for our final exam. It says the given angles in standard position determine the quadrant in which the angle lies. Well, this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. If you continue around here, this would end up being 360 degrees. So 308 is going to be in quadrant 4. Question 2 says draw the angle in standard position. So when I draw the grid and I label it in terms of pi, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and then come back here to be 2 pi. They want us to identify angle pi over 3. Well, pi over 3 is not quite as big as pi over 2, so it's going to be somewhere in here. So this is going to be, it is a standard position, which means it starts from here and goes this direction. So angle, or answer choice A is my selection. Question 3. It says convert the angle in radians to degrees. So you need to multiply 4 pi by 180 over pi. The pi values will cancel. When you multiply 4 times 180, you get 720. So that is answer choice D. Question 4 says find the radian measure of the central angle of a circle of radius r that intercepts an arc length S. We're going to use the formula S equals r theta. We're going to plug in our values, and when we solve for theta by dividing both sides by 4, find that theta is equal to 3, which means 3 radians, so that is answer choice A. Use the Pythagorean theorem to find the length of the missing side. So I've worked out the Pythagorean theorem here, and my answer is the square root of 106, so that's my hypotenuse. Then it asked me to find the sine. So theta is situated here. To find the sine, I'm going to need the opposite and the hypotenuse. And so that's going to be 5 over the square root of 106. The trig in this problem is pretty simple, but don't forget about the algebra. You can't leave a radical in the denominator, so I'm going to have to rationalize that by multiplying. Actually, I'm multiplying by 1. When you have the same thing in the top and the bottom, it's 1. What's going to happen here is I'm going to get 5 square roots of 106 over 106. So this is the answer, which is answer choice B. So question number 6, they tell me the sine and the cosine. Well, when they tell me the sine, I know the opposite and I know the hypotenuse. When they tell me the cosine, I know the adjacent and the hypotenuse. So I'm going to use those to help me with the cotangent. The cotangent is the adjacent over the opposite. So the adjacent would be 3, and the opposite would be negative square root of 7. Now, remembering from our last problem, we cannot have the square root in the denominator. So I'm going to multiply by the square root of 7 over the square root of 7. And that's the square root of 7. That will give me 3 square roots of 7 over negative 7. The negative sign can move from the bottom to the top. So that's going to give me answer choice A. Okay, question 7. It says a radio transmission tower is 240 feet tall. How long should a guy wire be if it's to be attached 13 feet from the top and to make an angle of 29 degrees with the ground? So I don't need this part in there, but our we have 13 feet left at the top. There's where we're going to attach our wire. The entire thing's 240, so it leaves me 270 here. My angle is 29 degrees, and I'm looking for the hypotenuse. So the sine of 29 degrees is equal to 227 over the hypotenuse. Now I'm going to make sure I'm going to press mode, and I'm going to make sure I'm in degree mode. And then I'm going to solve this. I'm going to multiply both sides by h. So h times the sine of 29 degrees is equal to 227. And then I'm going to divide by the sine of 29 degrees. So I'm going to have 227 divided by the sine of 29. And that's going to give me 468.2 feet, which is answer choice 7. Question number 8 says theta is an acute angle and sine is given. Use the Pythagorean identity to find cosine theta. So if we substitute in and we square the square root of 7 over 4, we're going to get 7 over 16. We're going to continue to solve. Cosine squared would be 9 over 16. The square root of that would be 3 over 4. It actually would be positive or negative 3 over 4. But because it's an acute angle, it means it's in quadrant 1. So that would mean that I would want the positive value there, which is going to be answer choice D. I also would tell students that if you know x and r, you can solve for y. The square root of 7 squared plus y squared should equal r squared. And then you would have 7 plus y squared is equal to 16. Y squared would equal 9 after you subtracted, and y would equal 3. If you wanted to use that because you know that cosine is equal to y over r, you could go back and use that as well. Question 9 says use a cofunction. So we have a formula on our formula sheet that says that it actually says that cosecant of theta is equal to the secant of pi over 2 minus theta. So I just plugged in 26 for theta, and I'm actually going to use 90 in place of pi over 2. And when I work that out, I'm going to get the secant of 64 degrees. So that is my answer, the secant of 64. Oops. This should be a y, and this should be x all the way through here, and cosine is x over r. I made a mistake. Please be aware of that disclaimer. Okay, I made a mistake on that one. This is correct. I had the wrong letter here. My apologies. Number 10, we have a point on the terminal side of theta given at 6, 8. Find the exact value of the cosecant of theta. Well, this is your x, this is your y. I would use the Pythagorean theorem to find your hypotenuse, which is r. So you're going to get 36 plus 64. It's going to be 100. You take the square root, so h is going to be 10. So we have 10 here. So this is your x, this is your y, this is your r. Once you know that, you can build any of these that you want. We're looking for cosecant, which is right here. So we want r, which is 10, over y, which is 8. And when you simplify that, you get 5 over 4. Since both of the x and y values are positive, this is going to have a positive value. So that's our answer there. 11 says evaluate the trig function at the quadrantal angle, or state if the expression is undefined. Well, we're finding the sine of 3 pi over 2. It's located here. That exact location would be 0, negative 1. This is your x value. This is your y value. Sine is what we're asked to find. So it's negative 1 over the r value here, which would be 1. So my answer is negative 1. Question 12 says cosine theta is equal to 2 over 9. And so there's your x value and your r value. And I used the Pythagorean theorem to figure out that y was the square root of 77. Positive or negative, I don't know yet. It goes on to say that tangent is less than 0, which means tangent is negative. So cosine's positive and tangent's negative. So let's find where we might be. Well, we got to be where cosine is positive and tangent is negative. So we are in quadrant 4. So that tells me that the sine is negative. So that must be negative y is going to be negative square root of 77. So we're asked to find the sine, and so that is sine is y over r, which is negative square root of 77 over 9. The point P is on the unit circle corresponds to the square root of 7 over 4 and 3 over 4. So this is where we would be located. If you want to use the Pythagorean theorem, r turns out to be 1. You're asked to find the secant. Well, the secant needs the r value over the x value. So when you take 1 and you place it over the square root of 7 over 4, basically what you get is 4 over the square root of 7. Now you can't have a radical in the denominator. Multiply by the square root of 7 in both, and you get 4 square roots of 7 over 7. And since x and y were both positive to begin with, we would be in quadrant 1, which would make all of our values positive. So there we go. Okay, so for number 14, we know that every time we go around the circle, we've gone 2 pi. So I've gone 2 pi, and if I go again, I'm going to go 4 pi. But 14 pi over 3 is actually 4 1/3 pi. So I'm going to have to go a little bit further. So there I am, and at pi over 3, if you'll use your unit circle, you will see that the cosine is 2/3 pi. My mistake. That's the second mistake today. Don't forget about the mistake in number 8. My apologies. 2/3 pi. 2/3 pi is going to be over here in quadrant 2. Now in quadrant 2, x is negative, so that is going to be negative 1/2. Okay, 15, ask us to find the amplitude. Remember that the amplitude is the absolute value of your leading coefficient here. So the absolute value of negative 4 is 4. I'm going to end this, and I'm going to start a new video tomorrow. So this will be part 1. So it'll be posted here in just a second.